Directional characteristics of covalent bond. Directional characteristics of covalent bond. Okay. Pauling and Slaughter modified VBT of Hitler and London to account for the directional characteristics of the covalent bond. Okay. Pauling and Slaughter modified VBT valence bond theory of Hitler and London to account for the directional characteristics of covalent bond. Covalent bond is formed by overlapping of atomic orbital. Covalent bond is formed by overlapping of atomic orbital. Formed is overlapping of atomic orbital. Okay. These orbitals must contain unpaired electrons of opposite spin, which are neutralized due to overlapping. The covalent bond is thus formed and the bonded pair of electrons is localized between the combining atoms. The bond strength of covalent bond depends upon the magnitude of the overlap of atomic orbitals. The greater the overlap, the stronger will be the bond. Okay. In case of greater overlap, the bonded pair is centralized between combining atoms, due to which nucleus repulsion is minimum and attractive force is maximum. The valence orbital of the element undergo proper hybridization before bond formation. So structures of molecules are governed by the type of hybridization. As S orbital is spherical symmetrical, it has no preferential directions. S orbital is not centralized in a definite direction. Okay. S orbital is symmetrical. S orbital is symmetrical. Okay. S orbital is symmetrical. It has no preferential direction. It has no preferential direction. It has no preferential direction. Okay. Is that S orbital is not centralized. S orbital is not centralized. Okay. In a definite direction. In a definite direction. Okay. Direction. P and D orbitals will tend to form bond in direction of maximum electron density. Comma P and D. P and D orbitals will tend to form bond in the direction of maximum electron density. Maximum electron density. Okay. P orbitals lies along the X. P orbitals lies along the X, Y and Z axis. Px, Py and Pz and are present at angle of present at angle of 90 degree to each 90 degree to each 90 degree to each other. Okay, 90 degree to each other. The D and F orbitals have also directional characteristics. Have also directional characteristics. Directional characteristics. Directional characteristics. Okay. Hence, due to directional characteristics, directional characteristics hence due to directional characteristics of P, D and F orbitals the covalent bonds have directional characteristics. Directional characteristics. This can be explained with following examples. Okay. Formation of ammonia gas. Formation of ammonia gas. Ammonia gas. NH3 molecule. Formation of ammonia gas NH3 molecule. In case of NH3 molecule, the central atom is N. The electronic configuration of N. 7 arrow mark of 1s2, 2s2, 2px1, 2py1, 2pz1. Okay. N has 5 valence electron. N has 5 valence electrons, out of which 3 are unpaired electrons. These unpaired electrons are in px, py, pz orbitals, which are at 90 degree. Which are at 90 degree. These p orbitals overlap with 1s orbitals of 3 atoms. These p orbitals overlap with 1s orbital of 3h atoms, forming 3 sigma bonds. 3 sigma bond. Okay. Form 3 sigma bond. These 3 bonds are laying along. These 3 bonds laying along. These 3 bonds laying along x, y and z axis. X, y and z axis. Okay. And angle between orbitals must be. Angle between orbitals must be 90 degree, but H and H angle is 90 degree, but H and H angle is 107.30 degree. The difference in angle occurs due to the difference in angle occurs the difference in angle occurs due to mutual repulsion between H atom, okay, between H atom, and due to hybridization which make bond angle greater, and due to hybridization which make bond angle greater, bond angle greater, okay. In pH3 the same type of overlap takes place, but the HPH angle is 93.5 degree, as size of P is larger in comparative to N. Size of P is larger as comparison to N. Okay. So the pH bond is longer than NH bond. The pH bond is longer than NH bond. Okay. Hence there is less repulsion between hydrogen atom of pH3 than NH3. That is why bond angle of NH3 is greater than the bond angle of pH3. Formation of NH3 molecule shown in the figure. Formation of NH2 figure. Okay. Formation of NH2 figure. This is the N. And H atom. This is N atom, and this is H atom. Okay. This is H atom. And this is PZ. And this is H atom. And this is H atom. This is H atom. This is H atom. Okay. This is PY axis. How axis? PY axis. Okay. Arrow mark of nitrogen, sigma bond with hydrogen atom first, sigma bond with hydrogen atom second, and sigma bond with hydrogen atom third. Okay. This is the formation of NH3 molecule. NH3 molecule formation. NH3 molecule formation. And formation of water. Next is formation of water, H2O. Next is formation of water, H2O. Next is formation of water, H2O, okay? Formation of water. Formation of H2O. Formation of H2O, okay? Formation of H2O. The central atom present in H2O molecule is oxygen. The central atom present in H2O molecule is oxygen. The electronic configuration of oxygen atom is O8 arrow mark of 1s2, 2s2, 2px2, 2py1 and 2pz1. This is oxygen. This is a central atom. This is central atom, okay? And oxygen is central atom. Overlapping of hydrogen atom. This is overlapping of hydrogen atom. This is overlapping of hydrogen atom with PZ, okay? PZ and hydrogen atom first, and this is the PY axis. This is PY, and one hydrogen atom is overlapping here. Hydrogen atom. This is hydrogen atom, okay? Hydrogen atom. So, as like this is oxygen. Hydrogen atom, bond formation, oxygen 1, 2, 3, 4, and hydrogen atom, the angle between this is 104.5 degree, okay? Oxygen has two unpaired electrons. Oxygen has two unpaired electrons in the outermost cell. These two orbitals, 2py1, 2pz1, 2py1, 2pz1 overlap with two hydrogen and form two sigma bond. In H2O molecule, the two oxygen hydrogen bonds are formed due to sp, okay? The overlap 2py orbitals of oxygen atom overlap with 1s orbital of 1 H hydrogen atom, and 2pz orbitals are oxygen with the 1s orbital of other hydrogen atom, forming two sigma bond, okay? The angle in H2O molecule should be 90 degrees. The angle in H2O molecule should be 90 degrees, but actually bond angle is 104.5 degree due to ionic nature. 104.5 degree due to ionic nature. due to ionic nature. Okay, due to ionic nature of oxygen hydrogen bond. Okay, there is a repulsion between oxygen hydrogen bonds due to which bond angle expands the other region. The expansion of bond is hybridization. sp3 Sankaram. The expansion of bond is hybridization sp3 in moving down a group, electronegativity decreases and size increases, hence the bond length will increases. Bond angle H2O bond angle 104.5 degree, H2S 93.3 degree, H2SE 91 degree, and H2 tellurium is a 90 degree. As above length increases, there is less repulsion between the bond and the bond angular come nearer to 90 degree. Hence, the bond formed by the overlap of s orbital are non-directional due to spherical symmetrical shape of s orbital. As p orbital is axial, hence it forms three types of bond. As p orbitals is axial, hence it is form three types of bond. Hence it forms three types of bond. Okay, first, with s orbital, p orbitals overlap axially due to which sigma bond is formed. With s orbitals, p orbitals overlap axially due to which sigma bond is formed. Okay. Second, when two p orbitals overlap coaxial, then sigma bond is also formed. Then sigma bond is also formed. Third point, when p orbitals overlap with another p orbitals sidewise or lateral, the bond thus formed is called a pi bond. The extent of sidewise overlapping is poor and hence pi bonds are weaker than sigma bonds. Pi bonds are weaker. Pi bonds are weaker than sigma bonds. Okay. Hybrid orbitals also have definite shape. Hybrid orbitals also have definite shape. According to type of hybridization, SP is linear. SP2 is triangular. SP2 is triangular. SP3 is tetrahedral. SP3 is tetrahedral. SP3D is triangular hybrid. SP3 is triangular. SP3 is triangular. Bipyramidal. Okay. SP3 is triangular bipyramidal. Okay. And SP3D square is octahedral structures. Okay. Due to presence of ionic pairs, symmetrical structure will change into unsymmetrical shape, but the shape and the number of atoms present in the molecules are fully directional. As example, ammonia and water. Hence, the above facts show that covalent bonds are directional. Hence, the above facts show that covalent bonds are directional. Covalent bonds are directional. Thank you. And next study is hybridization.